let's do a quick run through of various matrix properties or various operations with matrices. Okay, there is the concept of matrix addition. Okay, and it works very simply. So let's take as our example in all of these a 2 by 2 matrix, a 2 by 2 what's called a square matrix, where the number of rows equals the number of columns. In this case, 2 by 2. There is a concept of addition of matrices, so you just add each element individually. So the first row, first column element adds to the first row, first column element of this matrix, and you get this composite added matrix. Okay, we've looked at matrix multiplication already, but let's just quickly look at it again. So if you have this 2 by 2 matrix multiplied by this 2 by 2 matrix, you first take the row of this one and multiply by the column of this one. That gives you the first element of this multiplied matrix. So it will be A times P plus B times R will give you this first one. Okay, and then you go down through the rest of it the same way. So the next element here is going to be this same first row, but the second column. And this element here is going to be this row and the first column. And the last element is going to be this row and the column here. Okay. There's also the idea of a scalar. So we've talked about vectors and matrices. So a vector is like a 2 by 1 or 1 by 2 matrix. And a scalar is just a number. Okay, it's just a number on its own. Okay, so for example, the number k. If you multiply the number k times this matrix here, it's kind of like a scaling. You're multiplying each element by that scalar. Okay, so there is also this concept. I also want to talk about the idea of a transpose of a matrix. Okay, if you have a matrix M and it's A, B, C, D as usual, there is such thing as the transpose of a matrix, which will come in handy later, and it's just found by interchanging the rows and columns. So what was a row here, AB, becomes a column here, AB. And what was a row here, CD, becomes the next column here, CD. So it's interchanging rows and columns. This doesn't probably look like much, but you also have the idea of the transpose of a vector. So if, for example, you have a vector A, B, this here is a 2 by 1 matrix. 2 rows, 1 column. You can find the transpose of V transpose is A, B. Okay, this column has become a row. It works both ways. Rows becomes columns, columns become rows. So this is now a 1 by 2 matrix. Okay, but they're both vectors, just one is the transpose of the other. Okay, and then the last thing I want to highlight is the idea of the trace of a matrix. So if you have the matrix M, as usual A, B, C, D, the trace of the matrix is you add the diagonal elements. So in this case you add A to D. Okay, that's the trace. So these ideas will come in handy in the coming videos.